This is Mr. Anderson for Kellogg Community College. These are the next three story problems in Section 4, the applications of the quadratic formula. We're going to take a look at problems 5 and 7, which is going to be dealing with going up and downstream in a river. And problem number 6 is going to be a work problem. So here we go with problem number 5. Another distance equals rate times time problem. As you see that a current for a river is 4 miles an hour. That is the speed of the river. And then it says, how fast must a boat need to travel 24 miles upriver and return in a total of 5 hours? Well, let's set up our d equals rt equation again, our little matrix for that, rows and columns. Alright, so let's try to turn the story, the wording into actual equations for us here. The current of a river is 4 miles an hour. Alright, now what's important about that is that's important to the rate. So if you're going upstream, you're actually going against the current of the river. So you're going R minus 4. Now if you're going downstream, the current of the river is working with you, so you're actually going R plus 4. So upstream and downstream is going to change your speed based on how fast the river is going. Now we know that it says how fast must a boat need to travel 24 miles upriver and then return, so each of these has a 24 by them since the distance is the same, in a total of 5 hours. Well, we don't know how long it's going to take for the first time and the second time, but we know that adding those together, t1 plus t2, is equal to a total of 5. So like the previous problems in the previous page, we're going to isolate our T1 and isolate our T2 and then get what we need for our rate, because we need to figure out how fast must the boat travel in still water to go upriver and downriver in that distance. So let's go with T sub 1 first. I'm going to go 24 is equal to R minus 4 quantity times T sub 1. Divide both sides by R minus 4. And these simplify, so my T sub 1 is equal to 24 divided by R minus 4. So this is going to be 24 divided by R minus 4 right there. Okay, so we're going to move to the next part of this equation here. We're going to change to a different color. This is going to be our T2 equation, which is going to look a lot similar to this. 24 is equal to R plus 4 times T2, and then divide both sides by R plus 4, R plus 4. That simplifies out. So 24 divided by R plus 4, here we have it 24 over R plus 4. Now, since that is plugged in for our T sub 2, because there what we have left is 24R plus 4. So what we're going to do now is we are going to write everything else in blue. I'm going to write everything else in blue because nothing of that has changed colors here. So plus, and then it's equal to 5. So now all we have to do is solve for R, because we want to figure out how fast we must need to travel. And this is going to be an approximation right here, and just to warn you that when you actually do this problem you will not get an exact answer. So let's go compute the problem here. Let's rewrite this entire expression here, give ourselves a little bit of space, because here we have R minus 4 plus, and the 24 and the R plus 4 is equal to 5. Okay, so what this gives us here is we're going to now take a look at what would the common denominator be. The common denominator is going to be R plus 4, R minus 4, or some of you are noticing that R plus 4, R minus 4 is a difference of squares. But what this is going to do, it's going to clear my denominator, and over here I'm just going to FOIL this quickly. R plus 4, R minus 4 is R minus 16. Because there's not going to be anything to cancel out here or simplify to 1. Notice these simplify, and I have 24R plus 98. And here I'm going to simplify these out, and this is going to give me plus 24R minus 98, and this is equal to 5R squared minus 80. Now I'm going to move everything to the right side because I want this to be equal to 0, and that will help me set up my quadratic formula. Now the minus 98 and the positive 98, they simplify to make 0, so all I'm bringing over are these 24s. So I'm going to have 5r squared minus 48r minus 80. And what this will give me is this will give me an a, b, and a c, an a of 5, a b of negative 48, and a c of negative 80. Alright, so what that is going to give me is a quadratic formula that's going to look like this. 48 plus or minus the square root of the b squared minus 4ac, which works out to 3,904 divided by my 80, or my 5 times 2 times 5, which is 10. Now this is not going to be an exact answer, but because if I take the square root of 3,904, it's a decimal. So just go 48 plus your 3,904 rooted and divide it by 10, and you get an answer of 11.04. So you're roughly going to be traveling about 11 miles per hour in still water to get through up and down the river in 5 hours. Now if you subtracted, you get an answer of negative 1.45, which is not going to be an answer. When we do these story problems, we're always going to be taking the positive, not the negative answer in this situation. So the answer to the problem is you're going to be traveling 11 miles per hour, about 11 miles per hour in still water to get up and down the river, 48 miles total in a total of 5 hours. Okay, moving on to problem 6. For this next problem, we're going to remind ourselves back to chapter 6 about work problems. We had one of these on the test, and here's what it looked like. Let's say you had two people and they took different times to do the same job. Let's say, for example, that the first person took 12 hours to get the job done and the second person took 6 hours to get the job done. Well, what we'd have to do is set these two people equal to the one job. So person A plus person B, the person who took 12 hours to do it by himself, and this person doing it 6 hours by themselves, it was going to take them basically how many hours to do the job together. Now to do this, what you would have to do is you'd have to eliminate the denominators by multiplying everything by 12 here, which I can do, and that's going to be t plus, this is going to be 2t is equal to 12, which meant that 3t is equal to 12, and then t is equal to 4. So what this is saying is that if you have a guy who takes 12 hours to do a job and a guy who takes 6 hours to do the job, working together to do the one job will take them a total of 4 hours together because they're working together. And this is a kind of work problem, but instead of working it this way, this problem is a little stranger and a little different. So let's go and show you how this is done. So, using the same principle of something plus something equals 1, it says two pipes can work together to fill a tank in 4 hours. So here's what we have. We have 4 plus some amount of time, and then 4 plus some amount of time is equal to filling the one pool, or tank in this case. Now it says the larger pipe working alone can fill the tank in 6 hours less than the smaller one. So the smaller one is going to be our x, and our larger one is going to be x minus 6, because our larger pipe can do it in 6 fewer hours than the smaller pipe. Now to do this problem, I'm going to have to clear the denominator. So to clear the denominator, I multiply by the LCD, or x times x minus 6. X times x minus 6, and x times x minus 6. So what this does, it gets rid of all of our denominators, and the best thing about it is that it also gives us how to solve for x here. These x's go away, so 4 times x minus 6 is 4x minus 24. This x minus 6 goes away, so that 4x is just, well, 4 times x. And this is 1 times x minus 6, so that's x squared minus 6x. Now what I'll do is I'll move everything over to this side to get my answer equal to 0. So x squared can't combine with anything. If I subtract 4 and 4 from the 6, I get a total of negative 14x, because it's negative 6 minus 8. Moving the 24 over, that becomes positive 24. And now this whole equation is equal to 0. What's great about that is I get to set up my quadratic formula. So my a is equal to 1, my b is equal to negative 14, and my c is equal to positive 24. At this stage of the game, I think you should probably be assuming that when we go do our quadratic formula, so negative b, we're only going to be looking at the plus. We're not even going to mess around with the minus of it. So we're going to go plus the square root of b squared minus 4ac. Now if I actually do my b squared minus 4ac, I get an answer of 100. It works out to be a perfect radical over 2. So this means I've got 14 plus 10 over 2, which 14 plus 10 over 2 is 28 over, 24, haha, 24 over, oh crap, just can't hide that, can I? 24 over 2, which is going to be equal to 12. So how long would the smaller pipe working alone fill the tank? It would take 12 hours to do so. And that means my larger pipe, which was x minus 6, is going to take 6 hours to do so. By the way, if you rewind the video, do you notice that I actually did a problem that kind of set this up? So it's kind of funny that our 4 over our 4/12 plus 4/6 is equal to 1. In our last problem that we did, you know the one I did before I erase this one, you'll see that, oh man, I was actually solving this problem in a reverse order. I mean, again, you can rewind it and see how that all figures out, but it is kind of cool that way. All right, so here we go with the last problem of our worksheet here. Abby rows 10 miles upstream and 10 miles downstream for a total of 3 hours. All right, so let's get this straightened up here. All right, so we do know her total time, and her total time will be 3. So we know that our time sub, come on pen, time sub 1 plus time sub 2 is equal to 3. All right, so we make our distance equals rate times time box here. D equals R times T. And let's make my matrix like this. Okay, she went 10 miles upstream and 10 miles downstream, so there's the distance. Now, if the speed of the river is 5 kilometers per hour, find Abby's speed in still water. So this is going to be R plus 5 and R minus 5. Now, the R plus 5 is going with current, so this is going to be downstream. And this is going to be against the current, so this is upstream. And here's my T sub 1 and my T sub 2. Now, because we did this problem up above, I'm just going to do some quick conversions here. My T sub 1 is going to be equal to 10 divided by R plus 5. Because you see how I'm just dividing the R plus 5, underneath the 10. And my T sub 2 is going to be equal to 10 divided by R minus 5. See how I'm dividing both sides by the R minus 5 there. Alright, so I'm going to plug this into the T sub 1 and T sub 2. So I got 10 over R plus 5 plus 10 over R minus 5 is equal to 3. So what I'm going to do is I am going to multiply by my least common denominator. So therefore, I am going to multiply both sides by, or everything by R plus 5, R minus 5, R plus 5, R minus 5. And then, as I don't have anything to simplify here, if I multiply by R plus 5, R minus 5, that really is R squared minus 25, because it's a difference of squares. These simplify. This leaves me with 10R minus 50. These simplify, which leaves me with 10R plus 50. And then this is 3R squared minus 75. I'm going to move everything to my right-hand side. The minus 50s will simplify. The 10R's will be subtracted from this left-hand side. So this is going to make 3R squared minus 20R minus 75 equals 0. Now this will not be an exact answer, because as you do your A, B, and C, where your A is 3, your B is going to be negative 20, and your C is going to be negative 75, you get 20 plus, again, I'm not even going to mess around with the negative here because it's going to give us a non-realistic answer. This is going to be our b squared minus 4ac, which is going to be a total of 1,300, divided by 2 times a, which is 6. Now, if I compute this out, this gives me an approximate speed in still water of 9.34 kilometers per hour. And that will be Abby's speed. Alright, well, thank you for watching. These last two videos took a while, but I hope you found them very informative, going through these story problems that often get a little confusing, but with a little bit of practice, everything's going to be okay. Alright, thank you for watching.